Okay, guys, so let's discuss this weekly contest 376, which was held on last Sunday in the morning. So let's go through the first question. I know it's a bit late, uh, but I could not solve the fourth question in the contest, and later for making editorials, I could not get time due to my job. So yeah, let's go through the first one. So in this we are given a 2D integer grid in which let's say it's n cross n grid, then all the numbers from 1 till n square is present in that, and each integer appears exactly once except one number a which is appearing twice, and a number b is also there which is not there in the element. Right, like it's obvious if some number is being repeated, then some number will be missing. So we need to return those numbers which are appearing twice and which are missing. So this is a simple brute force. Like since n is given as 50 only, so n square will be around 2.5 thousand. So what I did, like I took a count vector to check whether and marked all those numbers as present, which are present in the grid. Like for each and every number in the grid, I made count of grid ij plus plus, and now I initiated a and b as -1, which are gonna be returned in the last. And I iterated through each and every number from 1 till n square, and if the count of I is 2, then I assigned it to A, and if it is not present there, then its count will be definitely 0 as I have initiated the whole array from 0. So I have assigned it to B, and at last I'm returning this vector A and B. Okay, let's go through the second one. The second one is like divide array into integers with max difference. So what this question is saying, you are given an integer array nums of size n and a positive integer k. You need to divide the array into one or more arrays of size 3 satisfying, like each element of num should be in exactly one array, like every number should be contained in only one subarray, and the difference between any two elements in one array is less than or equals to k. So for that, what we need to check, like what are the conditions, like it is given that n is always a multiple of 3, so we need not worry like any element will be left over after building the subarray. So what we will do, we will take first of all we will sort the whole array. Right, why this sorting is done, because we need to check this now, like the difference between any two elements in one array is less than or equals to k. So to make this possible, what we need to do, like to keep those elements in one subarray which are having the least absolute difference in between them, right? So for that we just sorted the array, right? And we have, since we need to return a vector of vectors, so I have taken one current vector and one answer vector of vectors, initially sorted the initially given array, and this is the first, second, and third, which I have named as f, s, and t. So this is nums of I plus 1, nums of I plus 2. So these are the three consecutive elements in that sorted array, and I am increasing as I plus equals to 3. So like what I'm checking, if the third one and the first one are having a difference greater than k, then there does not exist any partition, so I will return an empty array. Or else what I will do, I will assign that first, second, and third into the current, and in the answer I will be pushing this current vector, and at last I'm returning the answer. Yeah, so that's all for the second one. Let's go for the third one. The third one was a little bit tricky, like we are given an array and you are allowed to perform a special move any number of times. In one special move, you perform the following steps in the order. Like what we need to do, You can choose any index I in the integer range 0 till n minus 1 and a positive integer x, and add nums of I minus x to the total cost and change the value of nums of I to x. Like if I am increasing it to x, then also if I am increasing it by a value of, let's say, x, then also in the cost it will be getting added x, and if I am decreasing its value, then also the x amount of cost will be added to our answer. So we need to find the minimum possible value of cost to make the whole array equalindromic. What is this equalindromic? An array is considered equalindromic if all the elements in the array are equal to an integer y, where y is a palindromic number. So we need to convert all the array elements into one element. Like all the array elements should be similar, and that element should be a palindromic number, which, and it should be less than 10 power 9 also. Okay, so what does it mean? Like, let's say these are the numbers we are given. So if we convert it all these to 11, which is a palindromic number, 11 is a palindromic number, right? So we need to keep in mind two things: that all the array numbers should be same and it should be a palindrome, and also we need to do minimum number of minimum total cost. Considering minimum total cost, we need to do that operation, right? And what is that cost coming from? This, like if I am changing some nums of I to x, then it will be the absolute difference of nums of I minus x that will be getting added into the cost, right? So for that, what I am checking, like this, first of all I have sorted the vector, and if the nums of if it has a size of 1, then I will be returning 0, right? And what I am taking the median of the whole array. So this will be nums of n minus 1 by 2, right? And in the find, what I'm trying to do here, like I am first converting the mid value, and I'm checking whether what is the nearest palindrome to it, right? This is the function is palindrome. I have checked here, like this is the function for checking whether a string is palindrome or not. So what it will do, like for some number x, it will be checking which is the nearest number to x, which is a palindrome, right? So that I'm storing into this m value, and here two conditions arises, like if the whole array size is even and this m is less than equals to nums of n by 2, then I will iterate through the whole array, and in the answer what I will be adding, like the cost of each and every element getting converted to that m, like the median palindrome, the nearest palindrome from the median. So, and if it is not there, if that case is not there, then I will consider this one, right? And what is this drawing? Like this is all just for calculating that the current string, what is the uh, nearest palindrome to that string. Okay, so in such cases, like in some cases we are given with two, for some number we can have two palindromic numbers which are nearer to them, which are nearest to them, right? Like let's say we are given, okay, like there maybe some numbers like for which two palindromes are equidistant from that number. So for that case, we are returning this set of long long, in which in this function if you talk, like we are returning a set of long long. So this set will contain all the numbers which are equidistant from that array, and which are all from that number, and which are also palindromes, right? So, and then I am iterating through the whole set, and again through the whole array, and checking whether calculating the cost, and keeping count of the minimum cost, and at last I'm returning it. Okay, And if that is not the case, if this is not the case, this else is not the case, then I will return this answer. So this is basically for this if condition. Yeah, so that's all for the third one. Let's move to the fourth one, which I wasn't able to solve in the contest, but later on I solved it. So what this question is asking, like we are given an array of size, of some size, and an integer k, and what we have an operation to perform, like for any index I, we can change any number at that index. Like we can increase or decrease that element by one, right? And by doing that, we will change the array, and the score of the final array is the frequency of the most frequent element in the array, right? Like by doing this operation, what we need to do, we need to maximize the frequency of the max occurring element. Like if some element is occurring 2 times and if some element is occurring 3 times, then 3 will be the score of the array, as 3 is the maximum frequency of any element in that array, right? So like here you can see 4 is appearing 3 times, so and k is 0, so we can't perform any further operations on this, and we can't increase or decrease any numbers. So this will be the final array, and in this the maximum frequency is 3, so the answer is 3 only. So how do we do it? So for that first of all, like we need to select like which numbers, like let's say, sorry, like let's say we are given an array 1 2 4 6, and we are given with k equals to 3, right? So what we are checking here, like first of all we need to check like which number will be occurring, which number will be occurring at the maximum frequency, right? Let's say our maximum frequency is x, so which number will be occurring x times in there, right? So we won't be going for the elements which are not present in the array. We will definitely go for the elements that are present in the array. So one way is to do like the what will be the brute force of this. What can be the brute force? Like we will iterate through each and every element in this vector and try to convert all of the remaining, like if we go to 1 and we try to convert all the other numbers to 1, so how many operations does it take? So for converting all to 1, so for the first element it will take 0 operation because it is already 1. For the second element, which is 2, to convert it to 1, how much operation it takes? It takes 1 operation, right? Because we need to convert 2 to 1, so we need to decrease it by 1, so 1 operation will be needed here. So how many operations are we left with? We are left with k equals to 2, right? And for 3 getting converted to 1, we need 3 operations, but we are left with only 2 operations, right? So we can't convert 4 to 1, so it will be left as it is. And 6 will also, because it's definitely greater than 4, so it will definitely need more operations than 4, so all the further elements could not be converted to 1. Let's try to convert all to 2, right? So converting 1 to 2 takes 1 operation, right? So let's forget about this case for now. Let's try to convert all to 2. So converting 1 to 2 takes 1 operation. So converting, we are left with k equals to 2, right? Converting 2 to 2 gets 0 operation. Like 2 is already there, and converting 4 to 2 consumes 2 operation, right? So we are having 2 operations with us, so we can consume this and convert 4 to 2. Now converting 6, now we are left with k equals to 0. So can we convert 6 to 2? No. So 2 will be left as it is. So using k equals to 3 operation, what is the maximum frequency of any element we can achieve in the array? That is 3. So our current answer is 3. So like that we can check like what will be the maximum frequency that we can achieve, right? But one thing to notice, like what will be the time complexity of this? So first of all, we are iterating through each and every element and trying to convert all the rest of the elements in the array to that element, right? So what will be the time complexity? Isn't it n square? So by considering the constraints, which are around 10 to the power 5, I think, yeah. So it will be getting TLE, right? So to avoid that, let's see what we can do. I need a stroke eraser. Okay. So let's see what we can do here. Uh, okay. So we can perform a binary search like how do we do binary search? Like we fix a lower limit, like let's suppose it's 1, and we set a higher limit. And what can be the higher limit? The higher limit can be from uh, the higher limit can be the maximum element in the array, right? So we need to search in the range from minimum element to the maximum element, right? And what sorry, not this. What we need to check, like we will simply binary search on our answer itself, right? So this is binary search on answer. Sorry for the confusion, guys. So we will simply binary search on the answer. And what is our answer? Our answer is the maximum frequency of any element in the array, right? So we will binary search on. So what can be the minimum frequency of any element in the array? Like what will be the minimum answer? 1. And what can be the maximum answer? Like it can be n, right? Like all the array elements get similar, then it can be n, right? So we will binary search in this range 1 till n. Like can we make each and every can we make any element occur one number of time till n number of times? So we will binary search in this range. Okay, so for that what will be taking, like let's suppose some number are there, so we will take a low value of 1, right? We'll take a high value, so definitely there will be a mid. So we will check for this mid, whether we can convert all the numbers in such a way that the maximum frequency of any element is at least mid. Okay, so the maximum frequency of any element is greater than or equals to mid. How we will check that? So for that, like let's say some numbers are there like 1 2 4 6, like in the previous example. So let's suppose we need to convert all the numbers to this number 4. So how we will be doing that? So one thing to notice here is like you can check like how many like if you are given some value k, let's say, and let's say you can't convert all the numbers present in the array to this 4. Let's say you can't convert, mm, it is given, then which numbers would you try first to convert to 4? The numbers which are adjacent to 4, right? Because these will be these numbers will be having the least absolute difference from 4, right? So this will be consuming the least cost to getting converted and least cost for the maximum answer, right? So that's what we are looking into the code. Let's first go through the code. So here I have taken first of all we have sorted the array, and after that I am checking for this binary search while low is less than equals to high. So this is the frequency, we are checking whether mid frequency we can have in the answer or not. So if check of mid is correct, then we will be fixing our answer as mid, and we will go for the right half, or else we will move to our lower left half, right? And at last we are returning this answer. So how this check function is working, let's see. So in this frequency I'm passing this mid as the frequency. This is a lambda function in C++. You can go through this syntax, and I'm taking I'm taking a variable possible. So if this is possible, then at last I'm returning the possible value. And how I'm checking that, like let's say I am checking like if this frequency value, this mid value, is possible or not in the array, like any element can occur that frequency times or not. So for that, this is the required score I am taking. And what I am doing, what I am checking here is, like let's say if I am trying to have this frequency count of some element in this array. So what I am checking, I am trying to do a frequent a sliding window there, right? Like let's say we have an array like this, like 1 2 3 5 7 and 8, right? And let's say we are assigned with k as 5. So how we are checking, like let's say some mid frequency is there, so we need to check whether this mid frequency is possible or not. So how we will be checking that? We are taking a window of size mid, right? So let's say that mid value is 3 for now. So what we will be taking, we will be taking this 3 size window, right? And we will try to make each and every element same in this window. So if you know this, there is a problem on LeetCode and CSCS as well. Like if some sticks are there with some length, right? And let's say A1, A2 till AN are there, right? So we need to cut these sticks in one step. In one operation you can cut by one length or add one length to any stick. Then what is the minimum number of operations that needed to be performed to make all the sticks of equal length? What is the minimum number of operations? So it's, while solving that, what do? We first sort the whole array, and we take the median value, the mid value, right? And we try to make each and every element equal to this mid value, right? Let's say some array of n by 2 is there. If the array length is n, then this will be array of n by 2, right? So we will be trying to reduce or increase each and like the all the elements before a of n by 2 will be lesser than or equals to that, and all the elements to the right of it will be greater than or equals to that, right? So every element in the right needs to be left as it is or cut to gain that array of n by 2's length. So that's what we are doing here also. Like if we are putting a pointer I here and a pointer j here, then what will be the mid value? That mid value will be I plus j by 2, right? So array of I plus j by 2, we will be trying to convert each and every value there. Each and like we will be trying to convert this 1 into 2 and this 3 into 2 as well. So let's say this mid is something greater, like some value around 10 to the power 5. Then this calculation will be clumsy, right? This calculation will be a lot time taking, right? So for avoiding that, can we do some optimizations in that? Let's look. Let's look into that issue. Like, can we optimize that calculation? Can we avoid that calculation from now? For now, what we can do for calculating for from I till j, we will be iterating through each and every element and then calculating what is the cost of converting that current element to array of n by 2 or array of I plus j by 2, that is the mid value, right? Guys, just keep in mind that all these performance that all these actions we are performing after sorting, right? Then only you can calculate this one also, right? Like this operation we are doing, what is the minimum cost of converting all the elements to the median element, right? So now how we can do that? So we all know like the all the elements to the left of this, from I till I plus j by 2 will be lesser than or equals to this, and all the elements from I plus j by 2 till j will be greater than or equals to this element, right? So can we do a quick like calculation regarding how much cost will it take for all the elements in the range I till I plus j by 2 to get convert to array of I plus j by 2, right? That how we can calculate, like how much is the count, how much will be the count. So let's say if this value is mid, then let's say that value is m, I plus j by 2 is m, then m minus I plus 1 will be the count, right? So this will be getting multiplied with this value, array of I plus j by 2. So let's say this we mark as target t. So m minus I plus 1 into t. So this and this will be subtracted by the prefix sum of it, right? The prefix sum from this I till I plus j by 2, right? That's how we calculate like how much it will take for all the elements in the range I till I plus j by 2 to get converted to this target element, right? And what about the second half? The second half will be greater than or equals to that. So what we will be doing, the prefix sum in the range I plus j by 2 till j minus this, the how many elements are there in the range. Then if m is this value I plus j by 2, then what will be doing, j minus m plus 1 into t, isn't it? So this will be our, and adding both of these two will give our final answer, like to in that window till I, from I till j, converting all those elements into this target number, what is the cost, right? And we will compare it with our answer. So it's that simple. So we are taking I and j pointers, and while j less than n, we are in every step we are increasing I plus plus and j plus plus so that the window goes on moving forward. And we have taken a target element which is I plus j by 2, and this required value what will be, this get 1 is the calculation for the left half, that is from I till I plus j by 2, and this get 2 is I plus j by 2 till j, right? So this is for the right half of the array, right half of the window. So if that required is less than or equals to k, then we have found a window in which all the elements can be converted in such a way that the maximum frequency is this, right? So in that case, possible is marked as 1, and at last we are returning possible. So if that is a possible answer, like if that if that frequency can be achieved, then we will go for the greater numbers, checking greater numbers in the range 1 till n, right? So if I show you these calculations for what is the cost of left and right windows, so these are the functions. Yeah, so that's all for this contest. Okay, so yeah, that's all. Thank you guys for watching, and if you do have any doubts you can ask me in the comments. If possible I will attach the link of this the theory I've explained for calculating all the numbers, this question link, like for converting all the numbers to a single number, what is the minimum cost. So if possible I will attach that link. Okay, till then, goodbye, and we will meet for the next contest solution. Thank you for watching.